Assalamualaikum and hi to my panelists, Sir Saiful Bahari and Sir Shukri, supervisor and all my viewer for this video. My name is Muhammad Iqbal bin Zulkarnain and I will present about my final year project titled that is Prototype Development of Firefighting System in Car using Arduino Microcontroller with the supervision by my supervisor Sir Muhammad Fauzi bin Osman. I hope you will enjoy my presentation. This presentation consists of 6 parts. The first one is problem statement and the objective. The third one is the methodology. Continue with the result and discussion. The part 5 will be the demonstration video and the last one will be the conclusion and recommendation. So let's proceed with the first part. How the idea come out from this topic based on 3 main problems, that is fiery car crash fatalities, lack of research and driver hopeless conditions. Based on research have been made, there are 345 deaths, 1,300 injuries and 1.1 billion cost damages from 2014 until 2016 in US only. How about the world statistic? It much greater. 5% involve collision and 60% from fatalities reports from fiery vehicle. Based on research also show that there are lack of research have been done for this topic compared than the firefighting system for building or any high risk places. The third one is driver hopeless condition. Most of the case from fiery car happen after the collision. The collision that happen may put the driver or person or the passenger inside the car stuck, faint, and the worst case is death. Some research also show that Tesla driver stuck inside the car because of the malfunction of the door system and died inside the car after the fire happened. That's why the solution is of this problem is the firefighting system must be separately controlled and separately power supply is put inside the car. We proceed with the next part is objective. The objective of this project is design and CAD prototype. Design the CAD prototype. This can use any type of CAD software, but for this prototype I'm using CATIA V5. The second objective is develop complete Arduino program for the system, and the third one is fabricate the prototype that has been chosen in the CAD model, and the last one is testing and analysis towards the prototype that have been fabricated. To make sure the project success according to the objective, 4 main parts in the methodology needs to be successful first. The first one is design stage, followed by system orientation. Only after 2 parts complete that then we can proceed to CAD model and fabrication. It is because the design stage and the system orientation will decide how the CAD model will come out, and then we will be fabricate. The first part of the methodology is design stage. Several design has been made during sketching, random modeling in CAD model. The random research idea is sketching will go through into the engineering selection process that is consists of conceptual design, perk chart, function benchmarking, and morphological chart. The suitable CAD model is come out after the selection process have been made. The next one is system orientation. This system is using Arduino microcontroller to move the system. The placement for the electrical part is one of the important part to make sure the system is efficient during the hazard happen. The sensor must put in the correct place to make sure it will not easily triggered. The right of this slide is show the system flowchart. Boundary condition for each sensor will be set inside the coding, and the sensor will trigger according to the value that have been set. The relay will active and become switch to move the linear actuator, and the linear actuator will pull down the lever of the fire extinguisher and deploy the fire extinguisher powder. This is the CAD model that have been chosen after the design stage and system orientation have been made. Let's close up the view. This is the first part of the close up. It shows the system box that will place Arduino, breadboard, relay and power supply. The second part of CAD model show the placement of the sensor, the experimental box where the powder will deploy, the copper pipe that will deliver the extinguisher powder, and aluminium troller that are used for the demonstration that act as a car. The next part is extinguisher part system. This consists of 1 kg ABC extinguisher, L bracket to hold extinguisher bracket that will hold the extinguisher, iron cable that attached to the lever and linear actuator, and the actuator bracket is used to hold the linear actuator. The union flare is used to attach the fire extinguisher and the copper pipe. The next part is fabrication process. Several process has been done to make sure the actual prototype came out same as the final CAD model. The fabrication process is included flaring process that used to connect flare union with copper pipe, drilling and assembly process to connect all the item with the aluminium trolley, 3D printing to custom the system box, cutting and bending process for attach the copper pipe and experimental box to the system. This is the final prototype according to the CAD model that have been made. The aluminium trolley cannot be used to run the demonstration right now because the trolley is inside your ITM workshop, so that after the PKP student can't return to your ITM, so I changed the aluminium trolley with 2-tier rack to run the demonstration. This is the simple analysis has done to make sure the linear actuator has enough power to pull down the extinguisher lever. Based on the simple experiment, the minimum load needs to apply to move the lever is 40 Newton and the lever will move 10.1 mm. The minimum load need to be applied to make sure the lever is moved with the full motion is 43 Newton and the lever will move down with 26.8 mm. The linear actuator used in this project is 100 Newton and it's already fulfilled the design requirement. This is the performance characteristic for the groove flame sensor. The sensor has been set to the maximum and the minimum. The performance is consistent because the sensor is respond for less than 1 second every test that make the average sensor respond is 0.54 second and the average actuator responding time is 0.18 second. The average time to apply the average time taken to deploy a fire extinguisher is 3.99 second. The added around 3 second between the fire extinguisher time and the actuator trigger is because the spec of linear actuator is 50 mm stroke. The 25 mm stroke is very hard to get inside Malaysia. If you're using 25 mm stroke, the average time taken to deploy fire extinguisher is below than 2 seconds. The next one is the performance characteristic for the LM35V4 temperature sensor. The sensor cannot be set to the maximum and minimum because it fixed. The performance is not consistent during the test. It may cause the human error when the test be made because the distance between flame and the sensor can't be fixed all the time. The nearer the flame with the sensor, the lower the time taken it will take. The average sensor response is 5.94 seconds and the average actuator responding time is 6.19 seconds. The average time taken to deploy fire extinguisher is 9.38 seconds, same as flame sensor scenario. If it use 25mm stroke actuator, time taken to deploy fire extinguisher will reduce around 2 until 3 seconds. The next one is the performance characteristic for the MQ5 gas sensor. The sensor is set to the maximum and minimum. The performance is not consistent. It may cause the amount gas is not consistent during the test. The average sensor response is 3.30 seconds and the average actuator responding time is around 3.57 seconds. The average time taken to deploy fire extinguisher is 6.74 seconds, same as flame and temperature sensor scenario. If it use 25mm stroke linear actuator, time taken to deploy the fire extinguisher will reduce around 2 until 3 seconds. This is the comparison between three sensors used in the prototype. The faster sensor will make the extinguisher deploy faster. Faster sensor during the fire car crash is groove flame sensor with below 4 seconds can deploy fire extinguisher, followed by MQ5 gas sensor with 6.74 seconds and LM35V4 temperature sensor with 9.38 seconds. Let's move to the demonstration video. I'm sorry especially to my panelists because I can show the demonstration video for the temperature sensor and the gas sensor because I'm lack of the substance 1 kg fire extinguisher. Most of my fire extinguisher have broken during the shipping time, so I show the demonstration only for the flame sensor. The conclusion of this project is all objectives had been successfully achieved. The idea is delivered and the sensor has been used to the maximum capabilities. The next is recommendation for the prototype is upgrading the material for the pipeline system, upgrading with more advanced sensor implement inside the real car to have the real situation and use automatic valve at the fire extinguisher. Thank you to panelists, supervisor and all person that seen this video. This is my email and phone number. Thank you.